8th grade, we're working on section 9.3 today, which is functions. Now, a function is a special relationship. So yesterday we talked about relationships between numbers, and we were talking about linear functions today that mean we have one-to-one. It means that for every x value, there's going to be one y. And so we're going to determine today a couple tests to see if I truly have a function, a linear function, okay? So here it says each ordered pair of a relation has a unique x-coordinate, basically what we talked about. No two ordered pairs have the same first coordinate. Okay, and for each domain element, there is exactly one range. That's my one-to-one correspondence we learned about in the last two sections, okay? So one way to tell if we have a function is to use what is called circle mapping. Circle mapping is where I make a circle for my x values, and then I'm going to have a circle for my y's. And so this basically here is my domain, here's my range. Okay, then I'm going to go ahead and draw an arrow to my coordinates. So for every x coordinate, I'm going to draw it to where my y coordinate is. Okay, and what I want to make sure that is one of my x's does not go to multiple numbers. Okay, I want to make sure that it is going to one coordinate here. Okay, so let's do some practice here. Okay, so my instructions say use circle mapping to determine whether each relation is a function. So here's my first function. Remember, every function is named with a capital letter. And so I'm going to go ahead draw two circles here. And here's my circles. In the first circle, I'm going to put all my x values, okay? So I've got -2, -1, 2, and 3. And then I have my y values, okay? And I'm going to go from least to greatest with this. And so I've got 3. And if you notice, I'm only going to write my 3 just one time. I've got 4 and 5. Okay, so now we're going to take our map basically with our arrows and draw where it goes to. So my -2 goes to 5. My -1 goes to 4. My 2 goes to 3. And my 3 goes to 3. Okay, now we ask ourselves, is this a function? Does every x here go to a number? Okay, and none of these numbers are being shared here. We can share a y value here, okay, but our x doesn't have this same number, doesn't go to two different numbers, basically. I don't have an arrow for like number 2 that goes like this, where 2 shared it. If that happened, this would not be a function, but that's not the case here. Okay, in this example here for this function, every x here goes to one distinct y value. And so then, yes, this is a function here. Okay, let's do the next example below here. We've got n. I'm going to go ahead and do my circles again. And I'm going to line up my y's and my x's. So -1, 2, 3. And then if you notice, I have double 3s. I'm only going to write it once though. And then I look and write out my y. So I've got -3, 4, and 2 5s. Okay, now I just start doing my arrows. So -1 goes to 4. My 2 goes to 5. My 3 goes to a -3. And my 3 goes to a 5. Now take a look at my arrows. Does my x values here go to only one y? If you notice, take a look at my 3 here. How many arrows is coming from my 3? I've got 2 arrows. This cannot happen. So this one is not a function. Okay? So that is one way that we can quickly and easily see if our function is truly a function. Okay? Now, just a reminder here, talking about function notation. Remember, our functions are always named with letters. Okay, and a lot of times they use functions are F and G's. Okay, now a domain, remember, are always my x's, and my y's are always the range. So here, in this case, what were my x values? My x's were -3, 0, and 3. My ranges were all my y values, okay? So the value of the function f when x is 0 is 3. Okay, and how did I know that? It's just a fancy way of saying what is the y value when I have this x. Okay, and so that's what we're saying here. Now we can get very specific in our writing. It took a lot of words to say that. The value of the function f at 0 is 3. We can shorten it by doing this right here. Okay, this is shorthand for that phrase we just read off. So here's my function f. Here is my value for my x. So what we say is this is the value of the function of x. When x is 0, what is my y value? It equals 3. Okay, so this is a shortened way to write this statement right here. Because remember, in math, we like to take shortcuts. We don't want to use all this wording. So we use our math symbols to help us out here. Okay, so let's do some practice here. Okay, so I am told here in this problem that I want to find the value for my function of x when it's 3 and my value of my function at x is -3. Okay, and here is my function. So what I'm going to do is write the function, and I'm going to tell the reader what I'm putting in place of x by putting it in parentheses. Okay, and then I write out the problem. Okay, now all I'm going to do is substitute that x value in and solve. 2 times 3 is 6 plus 4. So the value of my function when x is 3 is 10. Okay, and we need to have this notation here. This is how I need to write my final answer so that my reader knows exactly what we're doing here. Now it asks me to do it one more time for when I have a new value of -3. So we're going to go ahead, put in my x value here in parentheses, write out the original problem, go ahead and do some substituting in for my -3. Follow through with my math. 2 times a -3 is -6 plus my 4. So my final answer is the value of the function when x is -3 is -2. And that right there would be my final answer. Okay, so that was a lot shorter than having to write out this nice long sentence. Okay, here in our notes, we're not going to go ahead and do it all again because we did the example up here. But here is another situation here. Here's my other function, the function of x when it's 3x minus 4. And they want me to go ahead and they want to find what the values are. When x is 0, when f of x is -2, and f of x is 2, and all of these, okay? When we're all done with it, they want us to write a function as a set of ordered pairs. Now, what do they mean by that? What they want you to do is to go ahead and we're going to write out our function, okay, in set notation. So once you find the values for each one of them, remember how yesterday we put it in ordered pairs? You would do the same. So when x was 0, your y value you'd write in there. When it was -2, you'd write it in there. And 2, you'd write it in there, okay? And that is all that they mean by writing a set of ordered pairs at the end there. Okay. So there's one other way that is a quick and easy way for telling if we have functions. And the way to do that is with a vertical line test. Okay, so what we're going to do is this works when we have a drawing. Okay, when we have a line that is drawn on a coordinate plane. And what we're going to do is take a vertical line. Remember, vertical line runs up and down. Okay, and we're going to do that line through a point in our graph. If that vertical line touches my graph only one time, then I know it is a function. It is a linear function. Okay, so we're going to take a look here at this problems here. Here I have a function. Okay, with a vertical line test, I can draw a line anywhere here. Does this line touch my graph, my actual plotted line here in one point? Yeah, right there. I can draw another vertical line here. Does it touch it in only one spot? Yeah, no matter where I go, my vertical line that I draw only touches my graph in one location. So this is, yes, a function. Now check this one over here. Okay, if I were to draw a vertical line through any point here, how many times does this vertical line touch my graph? It touches it in two spots here. This makes it not a function. With it to be a function with a vertical line, remember, it can only touch my graph in one spot. So this one touches it in two spots. So this is not a function. Okay, some of you see, oh, this was a U, and so this one here can't be a function. Well, don't get so cocky about it. Let's go ahead and do our vertical line test. If I do my vertical line test, yeah, it's a parabola is the correct name for it, not a U. How many times does this vertical line actually hit my graph? One time. How about if I drew it here? How many times? One. If I draw it here, one. So even though this is a parabola, when I do my vertical line test, this only connects at one spot. So yes, this is a function here. So the vertical line test is a quick and easy way when I have a graph to tell if I have a function or not. Okay, guys, you're going to practice telling me in your homework assignment what is a function and what is not. If you get stuck, look back in your textbook to see if that helps you, and then give me an email or a text message if you need more help. Have a good day.